Hey everybody, I hope you're having a great day and I'm excited to be here with you on your journey to learn Arduino and become an awesome maker. I know you can do it. In an earlier lesson, we talked about various control structures, including the if statement, the for loop, and the while loop. This time, we're going to learn about another control structure that's going to come in handy with some of your projects. We're going to learn about the switch case structure. Alright, so first of all, if you have any experience with C or C++ programming, you may remember this being called the switch statement. But Arduino calls it the switch case statement, so that's what we're going to go with since this course is about Arduino. Just know that they're the same thing with a slightly different name. So here we are in the Arduino reference, and right away we can see that, according to the reference, the switch case statement, or just switch case, controls the flow of programs by allowing programmers to specify different code that should be executed in various conditions. In particular, a switch statement compares the value of a variable to the value specified in case statements. When a case statement is found whose value matches that of the variable, the code in that case statement is run. Now, that may sound kind of confusing, and you may be sitting there wondering what the heck that even means. But don't worry, we're going to clear that up. First, let's start with a simple analogy most of us are familiar with, the traffic signal. And even if you don't have a license or live outside of the US, I'm sure many of you are still familiar with what the colors on a traffic light mean. As we know, there are three colors which mean three different things. Green means to keep going through the intersection, red means to stop, and yellow means to romp on the gas and get through the light before it turns red, or if you're more timid, then it means to slow down and get ready to stop. So, as you're driving along, assuming you're not in the middle of nowhere, you're bound to come to a traffic signal eventually, and when you do, you'll need to make some sort of decision about your driving based on the color of the signal. Alright, so you may be saying something like, okay Brian, this isn't driving school, so what does this have to do with Arduino? Let's get back to the Arduino reference page and take a closer look at the general form of the switch case structure. We'll step through this one part at a time. First, we see the word switch, followed by a space and the word var in parentheses. Var is the variable that the switch case structure tests. We'll see what I mean in a minute. But going back to our driving example, we may create a variable for the color of the traffic signal and insert that variable here. Let's just call it color since that describes the variable. After that, we have a space and then a curly bracket. On the next line, we see the words case and then label 1. The word case is a required part of the switch case structure, and I guess that's why Arduino refers to it that way. Now, the label in our driving situation would be the color. So, for example, we could write something like case green here. Notice the colon after the label. We'll need that for this to work. On the next line, we see a comment that just says statements, and this is the code we'd execute if the case tested true. For example, I could write something like this. Note that we could put several lines of code here. It isn't limited to just one, but for now we'll just keep things simple. Finally, we come to the word break. This is another essential part of the switch case statement. It causes the program to break out of the switch case and skip to the next statement after the switch case. Without it, every statement from the matched label to the end of the switch case would be processed, which would be bad. And we can see the Arduino reference confirms this. So let's tie this all together. Here we see the general structure of what a switch case for our driving example may look like. Of course, we have the word switch, and then our variable color in parentheses. We have our opening curly brace, and then we have our cases. We have case green, which means we should keep going. We have case red, which means we should stop. And then case yellow, floor it before it changes to red. And of course, we need break after each one of those cases after the code, as we can see here. So that kind of makes more sense now, I hope. But what about the last part, the default line? This is actually optional, but highly encouraged. This is the one that will execute if none of the other cases are a match. So going back to our driving example again, let's say the traffic signal is broken or something, and it's just switching colors every second or so from red to green to yellow, back to red to green to yellow. So there's no case to cover this, and the default case would execute, and we just park it and walk as it says here. Finally, when we're done with the whole switch statement, we close with another curly bracket. Now, before we move on, it's important to note that the switch case can only use integers or chars. If you remember from our lesson on data types, a char is a character, like the letter A or the hash symbol. This is true for both the variable we'll be testing against and the labels. So for our driving program to work, we need to somehow find a way to assign an integer or a char to the variable color and the labels green, red, and yellow. And I'm sure that wouldn't be terribly difficult, though. Now, if you paid attention to the Intro to Control Structures lesson, you may be wondering when or why you would use a switch case over the if-else statement. On the surface, they're kind of the same thing. For one thing, if we're using a float variable or expression, we'll have to go with the if-else structure, because the switch case only works on integers and chars. Another thing to consider is ease of use. For example, if a variable must fall in a certain range, it may be more convenient to use the if-else structure. Say we have something like this here. Using a switch case would require labels for numbers 3 through 999, which, though it would technically work, would be unwieldy and insane to code. It's also usually easier to use if-else if we have a lot of comparisons, like this code snippet here. But if you can use a switch case, your sketch often runs faster and takes less code. And as your coding skills increase, it'll become easier to tell which one you should use. Both have their merits and pitfalls. So that wraps up our intro to the switch case. I know it was kind of short, but we're going to come back to the switch case and do a real example really soon. See you in the next lesson.